session. In today's class, we are going to learn about the shear force and bending moment in beams. In area class, we have already dealt with the types of beams and statically determinate and indeterminate beams. What are the beams coming under statically determinate and statically indeterminate beam, as well as how a beam can be classified based on what parameter. Those kind of things we have already discussed in today's class. In continuation with the previous one, we are going to learn about the shear force and bending moment. Actually, a beam is there, a support, as well as here two supports are there. Number of loads are being applied. Let's take 100 Newton, and here UDL 10 Newton per meter. So here there is a beam having supports up to 2 ends, and we have at one point 10 Newton is a point load, and this is the UDL of intensity 10 Newton per meter. Okay, and what is called here shear force? So shearing force, a force laterally acting on the beam, that means transversely acting on the beam. Okay, we have to sum up, that is algebraic sum of all the forces are called the shear force. Okay, but here we have three axes. A, let's take this is B, and C, this is D. So totally you have AC, DB, CD and DB. Three regions are there. And how can we calculate these shear forces? So before calculating these shear forces, we have to know what are the sign conventions for shear force as well as the bending moment. Okay, so sign conventions we should know. So this is for shear force sign convention. Okay, so generally, let's take a beam at which we are going to find a shear force at each and every point. Let's take a point C. Here I am going to find the shear force at the C. Okay, so at a particular point you are going to focus on finding the shear force. You have to consider either right side or left side of the beam, either one side. Okay, so accordingly the sign convention will change. Here this is the sign convention for positive shear force. That means right down, left up. This will pass. Okay, it will move as a clockwise movement. Okay, clockwise movement will give you the positive shear force. Then if it is reversed, okay, if it is reversed, same thing. Okay, at a point, particular point, I am finding. Okay, now this is the upward, this is downward force. Okay, so forces will travel in the anti-clockwise movement. Okay, that means right up, left down. The forces are in the upward forces or downward forces. Okay, if I am considering only the right side, whatever the loads are being in the upward is called downward. Okay, it is the negative shear force. If I am considering left side, left up is positive, left down is negative. So right up is negative. Okay, so let's keep it in our mind. Left up, right down. Okay, left up, right down. This is for shear force sign convention. We will keep it this one as a thumb rule. Okay, if it is reversed, okay, left up is positive, left down is negative, right down is positive, right up is negative. So like that we can have the sign convention for shear force. Okay, I think you are getting the point. Okay, now let's have the sign convention for bending moment. Okay, first what is called bending moment? Okay, the moment is nothing but bending moment is the product of, okay, force into perpendicular distance. Okay, force into perpendicular distance, which will pass. Okay, let's take a beam here. Okay, I'm having point C. Anything, I'm having point C here. Okay, I'm considering the moment about any point. Right, let's have C. Okay, in between. Right side you are having the loads. Left side also you are having the reaction loads. Okay, so here if it is passing through like this. Okay. Now, whatever the force is on the right side, it will travel to a particular point. I am concentrating the moment at a particular point C. Okay. It comes to right side. So, it will travel in the anti-clockwise manner, okay, to C, as well as if I am taking instead of right side, I am taking left side. No problem. Okay. So, it will travel to the point C in the anti-clockwise manner. Both are called this is positive bending moment sign convention. Okay, and if it is reversed, okay, if it is reversed, so this is called negative bending moment sign convention. And one more thing I want to say, okay, if the point is there, here right side I am considering. So number of loads are there, okay, and load will travel to this point, okay. So a force, a vertical force is there. It travels to the point C. How it travel? Clockwise or anti-clockwise? So it should anti-clockwise. So the force must be a upward force only. Then only it travels to the particular point in the anti-clockwise manner. Same way, here also these forces will travel to C in the clockwise. Here also the upward force must be there so that it travel to particular point in the clockwise manner. Okay. So anyway, bending moment at a particular point can be considered if the loads are positive, either left side as well as right side. Okay. If the forces are towards vertically upward forces will produce the positive bending moment. Okay. So in this class we have seen how to take the sign convention for shear force as well as bending moment in the beams. Okay. So I think you are aware of these things. We will see in the next class how the nature of curvature for shear force as well as the bending moment diagrams will be followed. Okay, I think you will understand. I think so. Okay. So in this class, what we have seen, what is shear force, what is bending moment, and what are the sign conventions to be followed for shear force as well as the bending moment, and how to find the bending moment, the mathematical expression. Okay, so those things we have seen in this class. We will see in the next class with a different topic in the beams. Thank you.